Are you recording?
Yep.
Are you recording? Okay, good. This is Compound Miter Saw 101. Take 2. So I've done a video like this, and we have upgraded our saws, so I thought it was time for a reboot. Speaking of upgrade, we have gone cordless. Now this may be contentious, but we went battery powered. So on the back of this saw, there's a Milwaukee battery. Come in. I'm gonna check power here first. I got 3 bars, so I'm good to go. And battery packs, if we need to swap those out, we know where those are within the room. Right now I'm running with dust bag for collection. That's not typical. Normally we will have sawdust collection on and hooked up, and the system will be running. But so that you can hear me, we're doing the sawdust bag collection. Okay, what does this machine do? It cross cuts, and it will cut angles or bevels, so we can tip the head as well to do a compound miter, which would mean like angle plus a bevel. Mostly we use it for cross cutting, okay? This is a sliding compound miter saw, so we need to learn about that feature first. Come around to the back side here. Elam, right here, there is a knob on this saw that we can turn and tighten. And what will happen now is the saw cannot slide, okay? It just chops. So it's what we would call a chop saw at this point. If we loosen that, we get this slide feature. And what that does, if you look at the bed here, that allows us to cut up to like 14 inches of width here. And that's a great advantage, but it also has to be considered when operating it. Normally, we allow this to run freely. Sometimes, if it's new students or whatever, I will just lock it out here because that saw is gonna do 90% of what we need for cutting. And it eliminates a variable of the saw being able to slide out. So be aware that there are times where this might be locked out, or you may want to lock it out. We're gonna leave it floating free and show you how to operate it properly while it's floating free. Okay, other features on the saw. We're gonna start with a 90-degree cross cut. We may want to verify that the saw is actually true to a 90-degree cross cut and that it's also plumb and cutting at 0 degrees vertical. So what that looks like, we take our speed square, we roll the guard up by hand. Now if that guard is not floating freely. If you are not comfortable with this, you can pull a battery out for safety's sake. Get down on my level right here, Elam. Look down the blade, and then we want to bring this in with the heel on our bed and look at our angle. And we are really close there. We're maybe a ½ degree out. I typically check this now, and you can spin around to the backside. I don't expect students to be doing this. This would be a major adjustment, but we loosen here, and that allows the head to tilt. And this is where we get that bevel cut. So we want to go back up to our 0 point and lock in right at 0 to make sure we're getting perfect cross cut. Right there is very nice, yes. And now I'm going to lock it in on the backside. So now I'm cutting perfectly vertical, okay, at 0 degrees. I want to lay this down, put it against my fence or my backstop. The fence is where we rest material against. Bring it down in the same fashion, bring it over to the blade, and check to see that I am indeed at 90 degrees perpendicular to the back fence. And what would be 0 degrees on the gauge. So if we look at this gauge over here, it indicates 0 off of this, and it's locked in place. So I'm now at a perfect cross cut, which is usually what we're gonna want for building. We wanna build square, we wanna cut at 0 degrees. You can probably trust that this is good when you walk up to it, that we're checking it regularly, but you can see that that was actually off by a ½ degree. It just gets adjusted. So occasionally we need to check and verify that. How do we adjust if we don't want a 0 degree cut? If we wanna make a angled cut, how do we adjust this? On the Milwaukees, there's 2 independent functions here. There's a trigger lock right here that we can lift up, and that allows us to swivel this to any given degree between 0 and 50 actually. Actually, this saw goes to 60, wow. There are also detents, and if you come in here, these notches are what we would call detents. So if I let the trigger go right now and move to the left or right, it's gonna lock in to a given common angle. So right now I'm gonna swing over and lock into 0, which is common. But the next common one would be a 15-degree angle, 22.5. That's significant, half of a 45, right? So if we wanted to make a 45-degree angle, we'd cut two 22.5s. Let's go cross cut first. We're getting ahead of ourselves. 0 degrees, okay. Operation, we're gonna need a battery. Stance, how we hold material, all very important, okay? I'm left-handed, so it's comfortable for me to pin material with my left hand, operate the saw with my right. If I need to cut off a short amount on a board, I always want to think safety-wise that I do not want to try to hold the short side and do this, okay? I would want to flip the board. If I'm feeling comfortable pinning with my right hand, I want to flip the board, use my left hand to operate the saw. More importantly than anything, I never want to cross my arms when I'm using this saw, okay? So my mindset might be, okay, I need to cut this, so I want to hold it here and operate like this. This would be very bad, okay? And the reason is if you come back here in line, we never want to get our body in line with the cut path. So we should never have anything, any part of our forearm, hand, or anything that would be in line with the cut path of the blade. As long as I am here and here, nothing can happen to me. I'm not in line with the cut path of the blade. If I happen to, and this is a mistake I see often, students will think, oh, I need to take a little bit off of this. This block is probably too small to cut safely on the saw. Generally speaking, if the material is shorter than the width of your hand, you should not be holding it, bracing it by hand. You can use a stop block or clamp, or really probably ask me. The reality is if you need a little bit shorter 2x4, it's better to go over to our usable drops, grab a longer 2x4, make a little bit shorter mark, and make that cut. That's much safer than, the value of this is probably about 30 cents, so it's not worth risking injury. So generally speaking, we want to stay at least a hand width away. So I'll demonstrate that here. To actuate this saw, you got to look up in here, Elam, through the bottom, this way. No, yep. There's a flipper right here, and that is not obvious because you're going to grab this trigger and try and pull it, and it's going to be locked out. Most saws have some kind of a locking mechanism that stops you from just pulling. So you got to flip this to the side, and then it allows you to actuate the saw by pulling it to start it, okay? So I've got to be able to flip this before I can start the saw. Prior to that, I'm going to bring it down and line it up with my mark. Keeping in mind, look right in line with the saw here, Elam. I'll move the blade guard up. The saw is going to take material equal to the width of the blade. So I am lining up left edge of the carbide with my edge or line that I want to cut, knowing that I'm probably going to lose about 1/8 inch of material, which is called the kerf, okay? So I'm going to lose all that material, and I have to factor that. If I'm keeping this board and this is what I want, then I want to make sure that my blade is lined up to the outside edge or what's going to be waste on that saw, okay? So the guard will come up out of the way naturally as we articulate this up and down. I'm going to pin the material. Eagle flies in. No, let's do it. Okay, and lands on the bird, pins it to the water. No, that doesn't work. Lands on the prey, pins it to the water, okay? Thumb tucked in, so in line with my other fingers. Don't want to do this, just bad habit, okay? Keep your thumb tucked in, but I'm putting pressure down and back into the fence. Very important that I push up tight to the fence here. If I were to try and cut a piece of material floating out here, it's going to grab it and slam it against the back fence. And that happens, and we'll know it. We never want to leave a gap between the fence and the material or the backstop. Push that up tight, make sure it's seated tight, and then we can slide back and forth until we get lined up with our mark. We're going to pin it, tuck our thumb in. I will raise up a little bit. Now in this case, I'm pushed all the way back. I don't want you to draw the saw forward, down, and then through. Because what can happen here is the saw blade will actually pick up the material like this. Can you go back here? It'll pick up the material like this, slam it into the back if you don't have it pinned down tight. You could cut like this, but generally I want you to come down and try and start the cut right at the, what's the geometry term? Apex of this circle on the outside of your material, if that makes sense. Okay, so where this is touching is right on the outside, and then I'm just gonna chop straight down through here. I'm lined up, thumb is tucked in, I have the material braced. I'm gonna tell you out of habit to just let the blade stop and then raise it up. Because what can happen is if you raise up right away, dusty, it can catch that chunk and send that through the back, okay? So just as a habit, leave it down. You've got the time. It's got a break. Let it stop. Maybe I should have mentioned that when making a cut, let the saw come up to speed, okay? If I try and force it or cut right away, watch what happens. It's going to struggle more, and what usually will happen is you'll get a poor cut. It'll tear out. So that was, unfortunately, how not to do it, dumpster. Let the saw come up to speed. Let it stop. Now we can remove our scrap. If it's dumpster, goes in the dumpster side. Make sure we clean up after ourselves before we leave the workstation. Miter cuts, just for the fun of it. Let's make a 45. So if we wanted to make a 45, we would go to 22.5 here. I did not show you the other feature on this, so we have to lift this up in order to move it. But if we wanted to go somewhere other than a detented angle, so that's 15, let's say we want to go to 17. We move to 17 on the indicator, and then we push this down, and that is a miter lock that keeps the bed from moving left or right. This is maybe in the locked position when you find it, so you have to unlock it and then release this trigger in order to move it left or right. We'll go to a 22.5, okay, and we'll make a cut here, pin the material. I'm going at no certain distance. Cool thing about that is when we put that together, it makes a 45, but they're equal distant length members. So that 45-degree angle, and maybe I can show it better. I got all this here. Doesn't show it. Not a very good indicator. 45, you'll agree with me, okay? If I were to cut a 45 on this side, and now we're getting like, okay, definitely can't hold in here, right? So I want to always hold on the long side. Let it stop. If I take my 45 here and put it up against here, I get the same 45-degree angle, but the side lengths aren't equal. So I have to share those side lengths and cut equal angles. So two 22.5s add up to a 45. Two 45s make a 90. And this is the beauty of the compound miter saw. Now we can make a mitered corner and hide most of our interior. Well, if this was solid wood, we would have no end grain showing. That's the idea. Okay, so that's 45s. What else do we have to consider with this saw? I think we're going to show you the rest on the portable miter saw. Oh, I did want to show you a stop block feature. So this is a hold down that if we've got longer material, we can pin it down with this. You have to, the way I figure it or see it, you thread this all the way up, slide this up, bring it over, and now you got to thread it all the way down in order to clamp onto a block. Okay, we're going to choose a block that we know has a good perpendicular end to it. And this one is, oh, I didn't have the gauge right. How about that? That looks pretty nice. No, there, is that better? Is it good? Is it good? Okay. I'm just using a 2x4 as a stop block here. We can set a given length if we need to make 40 of something to whatever length we want by pushing into this stop block, bringing the saw down. Let's say we wanted 45-inch boards. So if you look along that, right now the right edge of the saw or the carbide is right onto my 5-inch mark on the tape measure. So I would then lock this in. And it takes a little bit to get it set up. Go slow to go faster. That's the idea. There we go. So that's solid now. And we could run our material through here and make 5-inch cuts all day long. Now I would say it would still be good to brace on this side. I worry a little bit about that being loose, but I'm right at the limit of, I'm 4 inches away from the saw yet. I can pin down and back against the fence and make my cuts. Really can't go much faster than that. We don't need to, but what this does is it automates this so that we get very consistent lengths. If you look across the top of those, they're going to be perfectly the same. So repeatability wise, a stop block is worth setting up if we've got a number of cuts to make that are the same. Okay, do a little bit of cleanup here. It's all dumpster, it's plywood. Put my tools away. Processes, we got to talk about that too. We never rip on a compound miter saw. So we would never try and cut a board this way. This operation, if we need to make this narrower, is for a bandsaw with a fence or a table saw. We only do cross cuts, and that has to do with wood grain as well. Like on real wood, the grain is running this direction. So think we're only doing cross cuts or angled miter cuts, okay? Never do rip operations. We're gonna look at the portable version of this and show you how to set this up. So this might be construction 2, SaberCon, or we use this in construction 1. This is a DeWalt stand for a Milwaukee saw. I'm just using what works best. There's a release right here that we have to, you won't have to do this too often, but this handle right here, we have to release this and then lift up, and that locks in. To send it down to the compacted position, lift up, push the release, and then this drops back down, okay, into storage. Up, locked in. We'll put the dust bag on. Most saws have an arbor tilt locking pin. It's right here on this saw. The DeWalt has the same pin. Makita's, whatever, they're gonna have the same function. You know, for transport, to move it, there's an ability to lock the head down. We have to pull this pin out. Come over here from this side. If we pull that pin out, it allows the head to articulate up. Push it in, it's locked for transport and safety, okay? So we're gonna pull that pin out so that it can articulate. Similar but not the same, come back here, we've got our miter slide that can be locked out to keep this from moving. And we will spin this over to 0 degrees here, perpendicular crosscut. Right now we are, on this saw, and this is interesting, on the 10-inch saw there is a lock to keep the miter from sliding. So that's locked right now, and it does not slide at all. Unlocked. On the 12-inch saw, oddly, there is no miter slide lock other than this. The 10-inch, 12-inch, this is a 12-inch blade, 10-inch blade. So the difference here is this has a little bit less bed travel. It can only cross-cut like 12 inches, whereas that one can do 14, something like that, okay? More common to see a 10-inch saw, a little less expensive blade, etc. Okay, so we just realized there is a lock, 2 different ways to lock this out. We could lock it out here and be locked to the back, which is kind of nice just for cross-cutting. We could also lock it out on the slides. It does have our stop block or our material hold down feature as well. Same rules apply here if we want to change angles. What we want to talk about next is if we're cutting longer boards that we can't pin or hold down. Let me give you an example. And we're going to use this guy even though he's got a real bow to it. Look at that. Not awesome material to build with. But if we had to cut it on flat, that would be more difficult because, let me show you. It's going to act like a banana, okay? I'm going to cut it on edge because on its edge it's pretty straight. But if I wanted to cut 4 inches off of this, I would have to be holding this down and pinning it, and that's really difficult. It's cantilevered way out, and so when I'm having to put all this force into it, it's kind of a more dangerous situation. So I can use outriggers, and they work like this. Loosen right here, this knob, and that allows the outrigger to slide out. You can go almost all the way out and then tighten that back up. Okay, and then how to set this to height. If you come down here, you'll look over the top of this bar. So if this board is straight and I slide it down, it's almost perfect right now. It meets with that surface. This one has been set to height, but it might be the case where it's low, and we're leveling off of this surface here. This is our flat surface, and we want this to be coplanar. So we're going to bring this out as long as it's even on our bed, bring this up until it just touches, and then tighten it in. We can also set stops here. So this is like a stop block feature that if we wanted to cut consistent board lengths, we can set this as a stop, and now we can bring our 2x4s out and continue to cut to the same length. Not very common, but that's a feature of the saw, and it's kind of cool. Most people just measure and mark and go with it. Okay, so we've got our outrigger set up. We're gonna do a cross cut here to take out this knot if we wanted to get this out of the equation. Same features. Well, this will cut a 2x4 on edge, but that's about as tall as it will cut. If we wanted to cut a 2x8, the blade is not tall enough to get all the way through this. It's going to run into the arbor here. On a 12-inch saw, the blade actually isn't long enough either, but the 12-inch will cut a 2x6 on edge. And sometimes that matters if we have to do a compound angle. And I think I'll demonstrate that. So I'm going to go 15 degrees this way. And this saw, well, right here, come back here, So all saws are similar, but not the same. To release and change the bevel or tilt, I have to unlock here, and now I can tilt over right here, Elam, to 15 degrees, and then lock that in. And now I have a 15 degree by 15 degree compound angle. I'm gonna make sure that my blade clears, which it does not. Right now it would hit this wing or backstop, because these are set in tight, so come around the backside again, Elam. Set screw, I'm gonna loosen that, and I can slide these wings out so that my blade clears all the way down and through. I wanna have these closer to the blade because they help support material, but not so close that we would cut through the sliding backstop. So I'm at a 15 and 15. I'm gonna pin my material. Let's make a couple of these. Now these are not very common cuts. Okay, they make, in this case, they're offsetting 15 degree angles. That's kind of cool. So it still ends up vertical. But they would make, so if we went this way, then there is your 30 degree angle, okay? But not very often that you do this. Like for hip roofs, we would make a compound cut that ties into a ridge beam. So if we had to butt into a ridge beam that was coming across and this was at an odd angle, that's maybe a situation where we'd use it, but not very common. So I'll reset it back to 0, 0, and then I'll also check this with the speed square. As you cut, it's easy to leave these materials in chunks lay around. Process as you go. Take this, put it in the firewood. If it's firewood, put your materials away in storage or under your table. Okay, another scenario that I want to prepare you for, or maybe I overlooked, is bracing the machine against running at you. Because it can slide, and because the blade spins this direction, it acts like a wheel that will run at you if you don't counter that with a controlled force. You got to use tricep here, brace, and be pushing back towards the wall. So in this case, I got a long piece of material. Table's great for that. I certainly have to make sure it's slid up against the back fence tight. I can slide it over to where I want to make a cut. I want to inspect my materials for knots, chips, fasteners, could be screws or nails in there. In this case, if I have to cut through a knot, I need to know that that is hard material and it's not going to want to cut. So I'm going to not brace this and allow it to run out to show you what that looks like, okay? To the, I guess, best of my ability knowing what's going to happen. That thing wants to come at me, so I have to be aware of that. Which means when I contact the material, I'm now pushing back and in. That's why we wear safety glasses. I'm now pushing back and in. You notice that I didn't even have to really brace this because this is so heavy. However, as long as it's pushed up tight against the back fence, it'll do the job. Cut through that hard material. Something happened in this tree's life that was traumatic. Look at that. Look at that heartbeat right there. That, I don't know. We started with safety. We finished with safety as well. So the last thing we do is make sure we take care of these and collapse the saw down. When it comes to outriggers, that wouldn't hurt, just so they don't be a catch for people walking around. Scene.